Ever wonder how Netflix predicts what movies you will love or how Google finds similar images instantly? The magic behind these technologies is vector databases. These databases use vectors, list of numbers that represent data features, to quickly and accurately compare complex items like images and text. They were designed to handle unstructured data that traditional databases can't manage effectively. In today's video, we will explore this cutting-edge technology by demonstrating a cool example using Bollywood movie plots. We will show you how vector databases can analyze and compare movie plots to find similar stories and recommendations. So what exactly is a vector database? Imagine you have a bunch of items like images, text, or even songs, and you want to compare them based on their features. A vector database stores these features as vectors, essentially list of numbers, and helps you find similarities between them. It's like having a super smart librarian who knows exactly where every book is and how similar it is to others. Why do we need vector databases? Well, traditional databases are great for storing and retrieving exact matches. But what if you want to find items that are kind of similar to each other? That's where vector databases come in. They allow for more flexible and powerful searches, which is perfect for applications like recommendation systems, image searches, and natural language processing. Let's look at some real-world use cases where vector databases shine. Recommendation systems. Platforms like Netflix and Spotify use vector databases to recommend movies or songs based on your past preferences. Image search. Google Images uses vector databases to find visually similar images. Natural language processing. Companies like OpenAI use vectors to understand and generate human language, improving chatbots and translation services. E-commerce. Amazon utilizes vector databases to suggest products similar to the ones you have viewed or purchased. Next, let's discuss some key advantages of using vector databases. Quickly find similar items based on their features. That's similarity search. Handle large amount of data efficiently. Scalability. Works with various types of data like images, text, and audios. Flexibility. Enhanced performance, faster and more accurate search results. Moving on to the implementation, our goal today is to create a small database of Bollywood movie plots and then find movies with similar plots. This hands-on example will help us grasp the fundamental workings of vector database. By the end of this video, you will see how powerful these databases can be for tasks like finding similar items based on their features. Before we dive in, let's outline our approach for the demo. Here is what we will do. We will start up using Replit, which is an online coding tool that helps us code and run programs right from our browsers. It's perfect for our demo because it's easy to use and requires no setup on your computer. Next, we will install the necessary libraries to work with vector databases and perform our tasks. We will set up a database where we will store and manage our movie data. After that, we will add data about movies to our database so we have something to work with. We will convert this movie data into vectors, which are numerical representations that will help us perform our similarity searches. We will then run some queries to find similar movies based on their vector representation. Finally, we will look at the results to see how well our vector databases is working and what we have learned from it. Before we move into the demo, we need to understand a concept called as L2 concept called as L2 Euclidean distance. So what exactly it is? It is actually a way to measure how far or apart 2 points are in the space made up of numbers. Say, imagine you have 2 dots on a piece of paper, okay, and you draw a straight line between them. This is nothing but your L2 Euclidean distance. It helps us figure out how similar or different two things are. The shorter the line, the more similar the images are. Right? Now, why do we need these L2 Euclidean distance? Because it is simple and works well with comparing items. As I repeat, it is simple and works well with comparing items. By measuring this straight line, we can easily see how close or far apart two things are based on their features. This makes it greater for finding things that are similar to each other. Besides L2 Euclidean distance, there are other measured distances as well. Like we have Manhattan distance. So this Manhattan distance is like measuring the distance by moving up, down, left or right on a grid. Just like how a taxi moves while it is driving on the streets of the city, right? The next distance we can talk about is cosine similarity. Okay, this cosine similarity measures the angle between the two vectors instead of the distance. It's useful when we want to know how similar the directions of the vectors are rather than their distance. Now, each method has its own use, but L2 Euclidean distance is often used because it is straightforward and easy to understand. Now, moving on to the demo, you've seen that I have opened Replit. I have just gone to the website by using this URL, https replit.com. This is the home page of your URL, Replit URL. So what you have to do is you need to create a Replit. That's a project, you can say. So you can click on create Replit. Since I'm going to create a Python project, I will click on the template Python, and here I will give the name as VectorDB demo. VectorDB demo. And I'm trying to create a Replit here. So you can see that the project directories are created for us automatically. And main.py file, that is main.python file, is our main file where we'll be writing the code. Before we try to write the code, we need to actually add a library which will help us in trying to have those similarity checks being done, right? So what exactly is that library? The library is called as FAIS library. That is nothing but your Facebook AI similarity search libraries. Okay, so we will try to install that library here. So the command to install that library is pip install . The command to install this FAIS library is pip install FAIS CPU, right? So I'll just click on enter. So a little bit more about your FAIS library is it will help you efficiently detect the similarity search and clustering of dense vectors, right? So using this library through your data is really quick and fast, as well as when you are using this library, it will help you in trying to get your answers very quickly. So this is a super important for things like recommending news shows on your Netflix or finding pictures that look alike on your Google. So here you can see that the library has been installed. So now we will try to write the code here. After installing the Facebook AI similarity search library, I'm trying to write the code in my main.python file. So this is the code for my main.python file. I'll just run through the code on what exactly we are doing over here. So here, first thing we are doing is we are writing the import, like we just imported the library, the Facebook AI similarity search library here. And after that, we are importing NumPy for numerical operations, right? So numpy we are using for numerical operations. And then we are trying to create a movie database with the name movie plots. And here you can see that there are 3 or 4 descriptions which I've given based on the movie plots. Like a man tries to reunite his family after his brother is accused of terrorism and so forth here, right? Okay, next thing what we will be doing is we will try to create a function that is text to vector function. This is a simple function which will help you convert your text into numerical values. After that, we are trying to pad the vector with zeros. Why are we doing that? So it is because that we are having the vectors different lengths can cause problems, right? So we are trying to have the similar lengths between the different vectors, hence we are padding it with 0 there, okay? And the next thing what we are doing is we are converting your each plot into a fixed length vector, right? So why are we doing that? So that this fixed length vector will ensure that every plot is represented in a uniform format, which will help us making it easier to compare and analyze it consistently, right? So after that, we are trying to use the set the maximum length of the vector as 100, and then we are trying to build your vector databases, right? Dimensions of your vector databases, and then you're creating your fastest index using your L2 Euclidean distance, which we just discussed now. And then we are trying to query the plot for search of your similar movies. So what is the query plot we are doing here is a boy from a poor family falls in love with a rich girl. So this has to be compared with our movie plots databases, right? So we convert the query plot into vectors. After we have converted the query plot into vectors, we will try to find the movies with similar plots, right? So this is what we are doing over here. We are trying to find the movies with the similar plot which is based on our query plot, right? And then we are trying to print the indices, that is the distance between them. As I said, since we are using L2 Euclidean distance, the smaller the distance, the more similar the item is, right? So that's what we are trying to do here. And similarly, we are trying to have another query plot here, that is a police officer takes down a dangerous criminal. This is our second query here. And then again, we are trying to print the indices based on our movie plots, what we have in our database, right? So now we will try to run the code here. So I'm just clicking on run here. So you can see that your library is imported, and then you can see the distance over here, that is a love story between a rich girl and a poor boy. Okay, so you can see that the distance is 150095, right? And then the plot, they say a police officer vows to take down the most powerful criminal in the city. It has a distance of 257946. Now they are just trying to compare it with our movie plots what we had added in our database. So they're trying to give us a similar plot here. So the shorter distance here you can see is 76042, which is a shorter distance for this movie plot, that is a love story between a rich girl and a poor guy, right? And then a police officer vows to take down the most criminals in the city, has a distance of 294673. So basically it is trying to give the similar plots which are there in your movie database. I hope you understand this. So that's how we will be analyzing the output here. That's a wrap on our introduction to vector database. Today we learned what our vector database is, why it's important, and how it can be used to find similar items based on their features. We even got our hands dirty with a simple use case using Replit. Remember, the possibilities with vector databases are endless, from enhancing search engines to improving recommendation systems. If you enjoyed this video, give it a thumbs up, subscribe for more tech content, and leave a comment if you have any questions or topics you'd like us to cover. Thanks for watching and happy coding.